Let me just record this. Okay, let's start. We've gone over all of these questions here. Did you do number 3? We're here. Question 3. So let's do number 3. We finished number 3, yeah? Okay. So moving on to number 4. Okay. Right. So did you answer this question? Charlie? No. Still behind. How behind are you? Huh? Exercise are we? So you're on 22, 20, so yes? Where are you? Where are you in terms of content? Huh? How far are you? 20, somewhere in the 20s. Yes? Huh? Exercise 19. Okay, please can you catch up? You need to catch up, ne? All right, so that we are at par. All right, okay. Helton, how are you?
Also.
Okay. All right, we are following the normal timetable, the one that we've been using since January, the day 1 to day 10 one, not the one that is on WhatsApp, ne? Okay, right, fine. Yes, in the back there, what's your name? Huh? Kujo, yes. Is it Kujo? How far are you? 20, yes. I can't see. When? Lisejo. Yeah, how far are you? 20? 23. This is Lisejo. I can't see this. Oh, okay. You came today. Yesterday you were not here, ne? You were here. Or you in the other class? Oh, I never came this time. Okay. All right. Yes. How far are you? How far are you in terms of content? $19. Okay. Yes. How far are you? Yes. 19. Okay. Yeah. You knew. Yes. 18. Huh? Be honest. If you be honest. You must be honest. I had the problems, need data and what. You must be honest. Don't lie. It's fine. We know there were challenges. The whole lockdown, you were sleeping and watching movies. You must be honest so that we assist. Yeah. How far? Where? You are far. Yeah. Where exactly? To do something. So which exercise are you on now? The one in your book? Huh? Come again? You don't know? Please double check. I want to know at the end of the lesson. Eh? I want to know. Yes? How far are you? I think you joined some of the lesson on Zoom. Eh? How far are you? So you're on exercise 24. Okay, fine. Yes? 18. Okay. All right, fine. So please don't, you don't have to lie, no? Because we need to assist. And so some of the topics we gonna because of lockdown, some of the topics you're not gonna be examined on. So the content is gonna be trimmed to 80%. So that 20% maybe is the one that you didn't do, so you don't have to stress. Are we together? All right, but it's gonna count for your that topic is linked to grade 12. We may have to do that so that we bridge the gap because you need the base before we do the other thing. You follow? Good. Right. Did I ask you there? Okay. All right, fine. So basically people are a bit behind in terms of content. So what we're gonna do, we're gonna continue with this topic here because it's term 3. We have to concentrate on the term 3. The term 2 one, there are loopholes. Since you're not gonna write your June exam, so we might not have to stress. But topics that are linked to grade 12, we have to do that. So we're going to continue with term 3, term 4. When we are done, then we can go back and bridge those gaps. Yeah? Okay, right. Shelton,
Yes, sir.
how far are you in terms of content? Which exercise are you on? We are on 24 now. Where are you?
12, sir.
Come again?
12.
12. Is it 12? I can't hear you nicely. Is it 12?
Exercise 12.
Exercise 12. Okay, fine. So please try and catch up. But as you catch up, you also need to continue with what we're doing now. Ne? Yeah. Okay, fine. WDKU, can you hear me? Okay. All right, fine. Okay, let's continue. So we're on question number 4. Right, on question number 4, your teacher asked you to use your knowledge of precipitation reactions. I'm just going to mute these guys. Mute all. Okay. There's some background noise. Maybe your young brother is disturbing you or something. Okay, fine. Question number 4. Your teacher asked you to use your knowledge of precipitation reactions to test the quality of water in the local river. Right, you are provided with the following chemicals. You've got silver nitrate, you've got barium chloride, you've got dilute nitric acid. All right. Which chemical would you choose to test for the presence of carbonates? All right. Before I do this, because people are behind, let me just try and open something here. I think people might be in the dark as to what is happening here. Let me just go to this. I'm poisoning this class. I'm poisoning this class. So next. Okay. All right. There's something that I have here. Is it precipitation reactions? Let me open this and see. Okay. Yeah, this is the one that I want. Okay, fine. All right. So initially, what we had, these are the tests that you have. All right. Under precipitation reactions, those of you, we've got this. All right. These are some of the ions that we have. We've got nitrates, we've got potassium, sodium in the ammonium salts, we've got chlorides, bromides, iodides, we've got sulfates. What is your sulfate? Is your SO4. Your carbonates is your CO3s. CO3 2 minus, no? That's a carbonate. Compound with fluorine, that's your F minus. You've got your perchlorates. All right, you've got your acetates, you've got your chlorates, you've got your metal hydroxides and oxides. Are we together? All right, so when you make reactions, you put them in water. Either they're going to be soluble or they're going to be insoluble. All right, they're going to form a precipitate. What is a precipitate? It's a solid that forms in a solution. Clear? All right. You said it's in this class. Okay. All right. Right. So what is a precipitate? A precipitate is like a milky kind of substance that forms something like this. So this is a precipitate. So it's going to be like milk, or inside is going to be suspended solid particles. Like when you put chalk in water, it does not dissolve. It becomes whitish, isn't it? Forms a white precipitate. That's what you mean by precipitate. So what is a precipitation reaction? It's a reaction that is going to form solid particles. Are we together? All right. So the solid particles will come with different colors. Others are white, others are yellow. Are we together? Depending. So the mind map that I have here, this is the mind map that I have. So we're going to be testing for chlorides. We're going to test for bromides. You need to know those tests. There's a test for iodide. There's a test for sulfate. There's a test for carbonate. All right, so you must know those 5. So it's chloride, iodide, bromide, carbonate, sulfate. Those are the 5 that you need to know. Okay, right. So there's a mind map that I've made here. All right. So if you take that solution, you don't know what is inside. So you're just given a colorless solution. You want to know whether any one of these 5 ions are present. So what are you going to do? There are 2 ways to do it. You can either add silver nitrate. When you add silver nitrate, all right, you're going to form 2 colors, 2 precipitates. Either it's going to be pale yellow or it's going to be white precipitate. Are you following? Right. Now, if it is white, it means either they are chloride ions or they are sulfate ions or they are carbonate ions. Out of the 5, 3 might be present. Are we together? Right? 3 might be present. 2 are left. Those 2, right? You're going to have your pale yellow. If it forms pale yellow, what does that mean? Either we've got bromide or we have got iodine. Are you following? Then the 5 are covered. So 2 forms yellow precipitate and 3 forms a white precipitate. Now, how do we confirm that this is a carbonate? Because we have got many colors here. All right, so what we have, you're going to add nitric acid. When you add nitric acid, what happens? You're going to see either there won't be a change, no reaction is going to take place. Then that confirms that it's a chloride ion. If you add nitric acid, if a gas is produced, then it means there's a carbonate ion. Are we together? There's a carbonate ion. Also, when you add nitric acid, no reaction, it also could mean there's a sulfate ion present. Are we together? But with sulfate, normally we use barium chloride. So with sulfate, if you have a non-solution, you add barium chloride, what is going to happen? Right? You're going to form a white precipitate. Right? Which means there's either a sulfate or carbonate. So if you add barium chloride to chloride ions, nothing is going to happen. Are we together? Right? But if you add barium chloride to something that is with sulfate and something that is carbonate, what are you going to see? You're going to see a white precipitate. You go a step further. There's a mistake here. I think here is supposed to be barium chloride, and here you are supposed to have nitric acid here. Nitric acid. I made a mistake here. I added those 2. So you're supposed to be adding nitric acid. When you add nitric acid, what is going to happen? Here, for sulfate ions, no reaction. All right? But for the other one, what are we going to see? We're going to see a gas being produced. Right? If a gas, you see bubbles, it means there's a carbonate ions present. So this is the background information that we're using to answer those questions. Are we together? For the benefit of those who haven't done this. Okay, all right, so that's just the mind map so that you understand what I'm talking about here. Okay, so let's look at question number 4. It says, you are provided with the following chemicals. You have got silver nitrate, barium chloride, and dilute nitric acid. Which chemical would you choose to test for the presence of carbonates? So you're going to go to that mind map again. We are looking for carbonates. So where do I have carbonate? I've got carbonates here. I'm going to use this, this route here. I can still get to carbonate. So it means I can use silver nitrate. Isn't it? All right. The question is saying, what is the question saying? Which chemical would you choose to test for the presence of carbonates? Which one are you going to use? All right. So according to this precipitation reaction, I'm going to use barium chloride. You can use barium chloride. But carbonate also works the other way. So here you can have more than 2 answers here. Okay. I need to open this page again. Solutions. I need the reactions in aqueous solution. Okay, let me just open it again. Reactions in aqueous solutions. All right. So we have barium chloride. So we have barium chloride. All right. So is our answer there? You have barium chloride. But the other way works is well, if you say silver nitrate, it's also correct. Are we together? You're going to add either barium chloride because both of them they form a white precipitate. Clear? as you can see from the mind map here, in this mind map. I can also get carbonates and sulfates. It's only sulfate that must go via barium chloride. It doesn't work with silver nitrate. But for carbonates, this will work. This channel here will also work. Clear? Right. Now, we move on to the next question. The next question says, use a balanced chemical equation to show the test for carbonates in question 4.1. Use a balanced chemical equation to show the test for carbonate in question 4.1. It's 4 marks here. All right. So it's 4 marks. So let me check here. Your carbonate and barium chloride, your equation, what is going to happen here? All right, you're going to do ion exchange. All right, so the barium is going to leave the chloride and go and bond with the carbonate to form barium carbonate. Are we together? All right, plus chloride ions. So you need to write this balanced equation here. How do you get the marks? You're going to get 1 mark for the reactants, 1 mark for the barium carbonate, which is correctly written, 1 mark for the chloride ions, and 1 mark for balancing. Is that clear? Are we clear so far here? All right. In this particular question, they are testing you the understanding of writing ionic compounds. You need to understand how to write ionic compounds. All right. This carbonate here, because you don't know whether it's a sodium, it's a potassium, you just write it as a carbonate ion. So you just write it as CO3 2 minus. All right. Plus barium chloride. That's what you're adding. If you're going to add silver nitrate, then this one becomes silver nitrate. Are we together? Plus, sorry, to give you barium carbonate. So if you're going to use silver nitrate, because it also works with silver nitrate, what are you going to say? I'll just write it here. If you're going to use silver nitrate, so that you understand what I'm talking about. All right. So I'm going to write carbonate two minus plus, instead of barium chloride, I'm adding silver nitrate because it also works. So I'm going to write silver nitrate. To give me, I need to know the answer that I'm going to get. So what am I going to say? I need to know the charges here first. So the charge is silver, I know it's +1, and nitrate is always a minus. Are we following? All right. Then there's going to be ion exchange. The cation, the positive one, will take the negative. So this silver and the carbonate, these two are going to bond. It's an ion exchange reaction. So the ions, they swap. Are we together? The one that was bonded to nitrate leaves nitrate and goes for the other one. If here, let's say there was sodium here. Let's say here there was sodium. If here there was maybe, let's say Na here. Sodium is Na plus. It means that sodium was going to take the nitrate. So they do ion exchange. Are we clear? But we don't know whether it's a sodium or a potassium. So here we're not going to write this because there's that. We'll just write carbonic ion. Right, so on the products now, what am I going to have? Remember what we did first time, crisscross, right? Crisscross, what did we say? We said, if I've got Ag plus, and I've got carbonate ions, CO3 2 minus. The positive here is 1. Positives, it's only 1 charge. And the negatives here, how many are they? They are 2. Then I'm going to swap this. This one must be 1, and this one must be 2. So my final formula becomes Ags must be 2. It must be 2 Ags. Ag2, and I've got the CO3. So the formula will be Ag2CO3. Remember what you did first time, no? Crisscross. Right, you need that for you to write the correct formula here. So the answer that I'm going to get here is going to be silver, Ag, Ag2, CO3. Plus right? Plus, then nitrate is no one to bond with or no ion to bond with, so you're just going to write it the way it is. So you're going to write it as NO3, NO3 minus. Are you following? All right. This one was aqueous, so you're going to write your AQ, aqueous, and this one is also aqueous. How do I know that it is aqueous? I'm going to go to the table and check. Right. How do I know that this one is aqueous? This is a carbonate and this is a nitrate. So I'm going to check on the table. Which table is this? I'm going to check. I opened the wrong thing here. All right, I'm going to check on my table on the notes here. I'm opening that up. Okay. That's not open. It's not open. Okay, all right. So what I have here, I'm going to check on the precipitation here. I'm checking carbonate on that table that I have. You can use either the first one or the second one. So I'm going to check carbonate. They're all insoluble except those of potassium, sodium, and ammonium. So I assume the first one would be maybe something like potassium and sodium. All right, so carbonates, they're insoluble, so they are solid particles. But the first one that we started, we assume because it was colorless, all right, we assume it's either bonded to potassium, sodium, or ammonium. Right, then the next one was what happened there, we had silver bonding to carbonate. So carbonates, if bonded to silver, they will be insoluble. So it means that silver that I had there, silver carbonate is going to be insoluble. Right? Then I've got the nitrates. Nitrate is going to be on its own. All nitrates are soluble. So it means aqueous. So wherever you have soluble means aqueous. Wherever you have got insoluble, it means solid. It forms a precipitate. Is that understood? That's how I know that I'm going to write aqueous or I'm going to write aqueous or precipitate. Right. I go to the other window that I was busy with, which is this. Right. So now I know carbonates. Carbonates are insoluble. So here I'm going to write solid. It does not dissolve. Nitrates, they are all soluble. So I'm going to write here aqueous. So the state here is going to be aqueous. It's going to be aqueous. Are you following? Right. That's how you complete that particular equation. So if you're going to go with silver nitrate, these are the answers that you're going to get. Right. Okay. We'll move on to the next one. I'm pressing the right one. Okay. All right, so let's continue. So we are now on question number 4.3. Both carbonates and sulfates form a white precipitate with a chemical reaction in question 4.1. So both carbonates and sulfates. So it means we have to use barium chloride because here they're saying both carbonates and sulfates form a white precipitate. And it only happens when you use barium chloride. Remember from that mind map that we've used here. All right? Both are going to form a white precipitate if you follow this. Right, barium chloride, then the two that happens here, we're going to have sulfate and carbonate. Right, remember here there's a mistake, it's supposed to be nitric acid here. Okay, fine. Right, then we move on. Use a balanced chemical equation to explain how you would confirm that the precipitate is a carbonate. All right, so what are you going to do? You're going to take whatever is formed in this reaction here, then you're going to add nitric acid and see. There must be a gas that is produced if it's a carbonate. So your answer is going to look like this. Barium carbonate, the one that formed, plus nitric acid. Where are we getting this barium carbonate? Is the one that formed in the first step. We're going to take that barium carbonate, we add nitric acid. So barium carbonate plus nitric acid. We go to the product. What is going to happen? It's going to be ion exchange. All right. The barium is going to take the nitrate to form barium nitrate. But look at the formula. What's your formula? It's Ba, and the NO3s must be 2. Why is it like this? It's because when you do your balancing here, let me just write this one so that you understand what I'm talking about. Barium carbonate plus nitric acid. Right, so we've got barium carbonate, the one that we formed in the first step, plus nitric acid, which is HNO3. All right, you look at the charges. Barium, okay, we start with barium is not on the groups, it's a transition metal, so that one might give you a challenge a bit. But carbonate, we know it's always 2 minus. And the ratio is 1 barium for 1 carbonate. So it means the charge here must also be 2 plus to balance the charge. 2 plus, 2 minus, since the ratio is 1:1. Are you following? Right, then we go to nitric acid. This one is going to be plus, and the nitrate is going to be minus. Now they do ion exchange. The barium is going to take the nitrate, all right? And you do your crisscross. You can do this mentally, or you can write it down. Barium is 2 plus. Nitrate is NO3 minus. How many positives here? 2. It's going to be a 2. And how many negatives here? It's 1. You do crisscross. So the nitrates must be 2. And the barium must be 1. So what would be my formula? My formula, when I write it down, it's going to be barium nitrate. It's going to be Ba, open bracket. I need to write 2 nitrates, and they are groups of atoms. So I'm going to write NO3. There must be 2, so I put a 2 here. Plus, all right, barium nitrate. Then I go to the second one. Second one, what I'm going to have? I've got carbonate. Carbonate here is going to form a gas, which is carbon dioxide. So I'm going to form CO2. Plus, there's still hydrogen here. There's still hydrogen here. That hydrogen is going to combine with one of the oxygens then. So it forms water, which is H2O. That's what I have. Clear? Right. Now, I do the balancing of this equation. This equation is not balanced. Barium here is 1. Barium here is 1. Carbon here, C is only 1 this side on the reactants, and here I've got 1, so your C is balanced. Then I go to my oxygens. Oxygen, I've got 3 plus 3, which makes it 6 on the reactants. On the products, I've got 2 times 3, which makes it how many? 6. 6 plus 2, 8. 8 plus 1, it's 9. So oxygen is also balanced. Are you following? All right. Then I move on. Sorry, it's not balanced, no. Because oxygen here I've got 3, and here I've got how many here? I've got 3 plus 3, 6. This side I've got 9. So here there's more here. Oxygen is not balanced. No? Oxygen is 3 plus 3, which is 6. This side I've got 2 times 3, which is 6, plus 2, which is 8. 8 plus 1 gives me 9. So this side I've got 9, this side I've got 6. I need to balance that. I check the hydrogen. Hydrogen I've got 1, and here I've got 2. Hydrogen is not balanced. Right. Nitrate, this NO3 is going as a group. So I can just look at it as a group. NO3 is 1, but here the NO3 is here. How many are they? There are 2. So I need to put a 2 here. So when I put a 2 here, the hydrogens are 2, hydrogens are 2, balanced. The nitrates, NO3s, because I've put a 2 here, it means the NO3s becomes 2, and the NO3s are 2. Now it's balanced. Is that clear? All right, so that's how you balance that. You go again a step further and put the states. right? Carbonate, we know this one didn't dissolve, so it was a solid. It formed a precipitate, so it's a solid. Nitrate, it's aqueous. Nitrates, they're always soluble, so it's aqueous. You check on that table if you're not sure what I'm talking about. Carbon dioxide is a gas, so I'm going to have a G here. And water becomes a liquid, so it's L. That's what I have. Clear? All right, so it's balanced. The states are there. Then the formulas are correct. Then you're going to get your marks. Depending how many marks are there, you're going to get 1 mark for the reactants. You're going to get another mark for the products. You're going to get a mark for balancing. This is for balancing. All right, you might have an extra mark for the states, right, to make it 4. So the question will come whether you've got 3 or 4 marks, depending with the person who settled that particular question. Right, any questions so far? Right, we've got 5 minutes left with the Zoom. So you're gonna, when we are disconnected, you join again. Our lesson ends at 10:30. Okay, right, we'll move on to the next one. The next question. So use a balance equation to explain how you would confirm that the precipitate is a carbonate. So how do we confirm? There's carbon dioxide that must be produced. There's a gas that must be produced. So you're going to write that equation and you balance it. 4 marks. So you're going to get 1 mark for the barium carbonate plus nitric acid. Provided the formulas are correct, get a mark. Then you go to your product. There's a mark for carbon dioxide, a mark for water, a mark. And the states there, the gas and the liquid. Then you get 1 mark for balancing. All right, this one is not balanced here. So you need to have a 2 here. There must be a 2 here, right, for you to balance this equation. It's not balanced. You need a 2 there. Like I showed you how to balance it there. Right, we'll move on to the next one. The next one, what does it say? It says give the chemical name of the precipitate formed when carbonate and the chemical in question 4.1 react. Give the chemical name of the precipitate formed when the carbonate and the chemical in 4.1. So we are going to 4.1, all right? We saw that carbonate reacts with barium chloride. What is the name of the precipitate that formed? What did we see there? What is the name of the precipitate? It was barium carbonate, all right? So the answer here is barium carbonate. Right, for 2 marks. The answer is barium carbonate for 2 marks. They want the name, not the formula. So you're going to have to write the name. Clear? Right. We'll move on to the next question. Question number 5. 5.1, many chemical reactions take place in aqueous solutions. Define the term aqueous solution. What do you understand by the term aqueous solution, guys?
Sir,
Yes.
so how many minutes are left again?
Come again. How many?
How many minutes are left, sir?
We're left with 3 minutes, so we're gonna disconnect. Then you reconnect again. Our lesson must end up at 10:30.
Oh, yes, sir.
Yeah. So if you are disconnected, join again using the same code. Ne? Right. Lisedi in the Galaxy J7 Duo. We are following the normal timetable, please. So now it's science. So check on the WhatsApp group what will be the next period. We're not following the timetable that was there before, the one for 1 hour, 1 hour. We're following the normal timetable, the one that you use when you're at school under normal circumstances. That's the timetable that we are following. Right. Okay, so there will be lessons for 10x, then there will be lessons for 10y. So if you're in 10x, you need to follow 10x. If you're in 10y, you follow 10y, because there's going to be different subjects at different times. Okay, right, so 5.1, many chemical reactions take place in aqueous solutions. Define the term aqueous solution. Right, what is an aqueous solution? Aqueous solution, it's a solution in which a solvent is water, all right? Aqueous solution is where the solvent is water, that's aqueous, all right? I think that's not the only way to define it. There could be other ways. It could be in solution with water. You can just say it's when a substance is in solution with water. Aqua, from the word water. So aqueous solution, it means something is dissolved in water. Is that clear? Right. So solution in which the solvent is water. So something that is mixed with water, right? Or something in solution with water. Right. We'll move on to the next one, 5.2. Ionic solids dissociate when dissolved in water. Define the term dissociation for 2 marks. The term dissociate. All right. If something is one thing, then you dismantle it, right? You are breaking it apart. So to dissociate also it's like that. Like you've got salt. Salt is sodium chloride. So if you take your sodium and your chloride, or you take salt, you put it in water, the sodium splits or dissociates from the chloride, isn't it? Right. So let's look at the definition here. It's the process in which a solid ionic crystals are broken up into ions when dissolved in water. So if you take salt, you put it in water, it dissociates. Are we together? Into its respective ions. So you're going to get cation and you're going to get an ion. But if you put sugar in water, it does not dissociate, it dissolves. There's a difference between dissociating and dissolving. Sugar dissolves, and sugar does not form ions. Why? Because sugar is a molecular compound. So when you dissociate, it means you are going into the positive and negative ions, your cations and the anion. So it's the process in which a solid ionic crystal are broken up into ions, right, when dissolved in water. Clear?